Hello everybody, today we're going to learn about what the boundedness theorem is. A few lessons ago we did the rational root theorem, which allowed us to create this giant list of possible roots. And all of the theorems we have learned since then are just ways of narrowing down that giant list. This is one of them. So the theorem is, and it's shown over here, another way to just, again, reduce down the list of possible zeros. And this one's going to use synthetic division. So if we have a polynomial, the degree is greater than or equal to 1. That's just kind of standard there. Real coefficients, positive leading coefficient. If we take that polynomial and divide it synthetically by x minus c, and c is greater than 0, meaning c is positive. So when we do that synthetic division, and all the numbers in the bottom row are non-negative, in other words positive, that means the polynomial has no greater 0 root solution x-intercept than c. And on the contrary, if that c value is a negative or less than 0, and all the numbers in the bottom row of synthetic division alternate in sign, plus, minus, or other way around, minus, plus, then p of x has no 0 less than that c value. If you get a 0 in that bottom row of synthetic division, you can consider it positive or negative as needed. So if you went from -2 to 0, that would count as a sign change. So let's go ahead and see this in action. So we're going to show that the real zeros of the polynomial p of x satisfy the following conditions. So we want to show that there's no real 0 greater than 3. So in that instance, our c would be greater than 0. So we're following the first bullet in this note packet here. So that would mean our c value is 3. That's what we're using out here in the long division. I'm going to fill the top row with the coefficients. Notice we go from 4 to 3 to 1. So we've skipped over the x squared term, so make sure we leave a 0 there. And you can feel free to stop the video at this point, try out the synthetic division, and come back to see if you're done, or see when you're done if you've got the right answer or not. I'm going to continue on. Bring down the 2. Multiply. 6 times 2 is 6, and I'll just continue on here with that same pattern. So now that I finished the synthetic division, take a look at the bottom row. The bottom row of synthetic division, so go ahead and think back to that bullet, look back in your notes where you wrote that down. If the bottom row is all non-negative, then that shows that p of x has no greater 0 than 3. And that is, again, because that c value is greater than 0. That's why we're following that top bullet in the notes that I just showed you a second ago. P of x. So that means this polynomial has no roots, solutions, zeros, x-intercepts, places where this polynomial crosses the x-axis. None of them can be bigger than 3. And now we're going to do another one. No real 0 is less than 1. So we're going to use the same polynomial up here to show that no real 0 is less than 1. Negative 1, excuse me. Change that to a negative 1, because that will be a c value then that is less than 0 or negative. So then we will be following the second bullet over here. So if we do the synthetic division here, negative 1 out in front, and again, the coefficients, same as these over here, as the top row. In this instance, I don't even need to put this vertical line here. The remainder doesn't matter. For this one, we're just looking to see if there's sign changes. So again, feel free to stop the video and do the synthetic division on your own just to see if you can do it without my help. So now that the synthetic division is done, just following along with that second bullet that I had, when C is less than 0, that's what that is, and the bottom numbers, bottom row of synthetic division shows that the numbers here are alternating sign, positive, negative, negative to positive, positive to negative, negative to positive. Then it's showing that P of X has no 0 less than -1. And that's all that the boundedness theorem shows you. And so your homework for this lesson is down here, page 235, numbers 77 to 83 odd. Again, answers are in the back of the book. And please be advised, guys, that there is going to be a test next week, okay? I will have more information about that on Monday's video. Until then, have a good weekend.